Hello and welcome back, and that is right, it is time to do our temperature tests on the Elecgear heatsink for PS5. We've already done a full hardware review and I showed you some of the results. This is the video where we go through the entirety of all of those tests. Now, it's worth bearing a few things in mind, a few disclaimers straight off the bat. First and foremost, the SSD that we're going to be utilising inside this PS5 for today's testing is this. This is the Team Group T-Force Cardia A440. I've selected it for several reasons. First and foremost, its architecture of a Phison E18 controller combined with 96-layer 3D TLC NAND is incredibly similar to the majority of SSDs that are supported by this system. Secondly, I'm utilising it because although it arrives with heatsinks, none of them come pre-attached. It is a completely clean, clear heatsink that will allow us to utilise the thermal paddles and that larger heatsink inside here. Another disclaimer we should probably add straight off the bat is about ambient temperature. These tests have been recorded on November the 28th, and on November 28th when these tests were conducted it was quite cold here in the UK, and although ambient temperature inside this system is being measured, we've got one thermal node on the controller of the SSD and another one in the ambient area, and I will be dismantling this in a moment to show you. It's worth bearing in mind that in future videos, and indeed at points in this video when I compare against other heatsinks that are for the PS5, they were all recorded at different times of the year, on different days, at different times of day, and this can have its impact on ambient temperature. So bear that in mind. So when we look at the results, although in every single test we are looking at the starter temperature and the end temperature, the actual numbers themselves aren't really what we're looking at. What we're looking at is the difference between them in the positive or the negative, and that is how we gauge how well these heatsinks are working. We want to know that they dissipate heat as well as possible, because remember, it is not just about the heatsink protecting this SSD. Yes, that's important, and one of the main reasons for a heatsink is to protect an SSD enough for its longevity and to last for a long time and to make sure performance continues, but also it's very important that that is not done to the detriment of the performance of the system. That's why we've got the general internal temperature, which is conducted inside that sleeve, and another one directly on the controller of the SSD. We want to see how both of them fare. Having one really, really cold and the other one really, really hot is no good to us. They've both got to be good numbers there. On top of that, we're going to be running GTA 5 and Red Dead Redemption because they're open world games that we can run moderately on autopilot on the highest settings we can, and they're going to be running for 25 minutes each. We're going to be running a test again. Both games are going to be testing the controller temperature of the SSD, that's the brains of the SSD that gets the hottest, and the ambient temperature of the system during those tests, and we're going to run them one after the other. So even though on screen you're going to see the controller temperature and the surrounding temperature, know that the controller temperature was done first, then we left it, we quit out of the game and then loaded the game again 1 minute later and then recorded 25 minutes of the ambient temperature there. The other thing I want to highlight is we are comparing these temperatures for a sense of relativity versus this. This is the Eluteng. This is kind of the go-to easy budget option. I've talked about it before. The Eluteng heatsink was one of the earliest heatsinks I recommended. It knocks around for about 10 quid or $10 to $15. It's really cheap, it's available everywhere, it's a nice, easy, straightforward installation. The SSD goes inside there. So what we're looking at here is how well this premium PS5 designed heatsink compares in heat dissipation and general utility and temperature versus this budget option here. But I think that's enough breakdown there. So first thing we're going to do is have a little look inside before we get to the results. So this is our temperature reader. If I turn that on there, you can see a number there on screen. That tells us that right now the temperature of the controller on this turned off PS5 is 18.9 C. Now again, we can flick this button here, and that flicks us over to the ambient temperature in the system. As you can see, they're largely identical. The system is off, it's not been turned on for several hours there. So again, when you're watching this, those are the numbers that we're going to be looking for there, the internal and the ambient. The other thing I'll highlight there, when this is in operation, this reader turns itself off every, I believe it's 8 to 9 minutes. So occasionally during the speeding up of that footage that you're going to be watching, you're going to see my hand go like that. The screen turns off, I've got to turn it back on. So when you see that, don't worry, that's all that is. So let's open this up on the side there, and I'll show you how I've distributed the nodes inside this system. Here's our top panel removed there. Again, you guys always ask this in the comments, and I've mentioned it before. If you are interested in the PS2 design of this, there should be a link in the description to the article where I've told you where I've bought all the bits. I've answered that question a lot in the comments. So as you can see, that is our general layout inside there. There is, let's get the thumbnail sorted, shall we? There we go, that was easy, wasn't it? Thanks for doing that solid for me, it looked great. So down here, we have got that heatsink there. On top of that, underneath there is the SSD. Hopefully there should be photos on screen. If not here, then in the article in the description where I've shown you that I've threaded this with the thermal node directly onto the controller in the middle of this SSD. The controller is in the middle of this one, so we've got that directly on top of there inside. So again, if it's not already on screen, go to the link in the description. And we've got the secondary node up here that's going to be taking care of the general temperature of the middle of the system. I was thinking about putting it at the top, but that are our vents, so we don't really want to look at that. So again, as we run this in operation, the key thing we're looking at here is this panel here that's got these slits built into the side of it, and again, I hope you watch the hardware review, that's got the air being drawn through and pushed out the back there, over these slits, over the edges here, going to make sure that this heatsink dissipates that heat as quickly as possible, and is it going to steal some of the airflow and therefore ruin the temperature of the ambient here at the bottom and the overall system temperature there. But when we run these tests, we put the panel back on like so. Let's put that there. None of these tests have been conducted with this side panel off. There's no reason, please don't do that. We'll slot that on there, and there we go. So let's go ahead and go into our results of temperature testing on this heatsink here in the PS5 today. Okay, so our first test utilising this new heatsink was utilising Red Dead Redemption 2. And again, this is on the PS5, but this is of course the PS4 version of this game. Now, we are comparing the Eleten heatsink, that $10 one, versus that of the Elecgear one with the copper inside. Huge price difference between them. And the first test we wanted to look at was, of course, the controller. For those that aren't aware, the controller, the brains of an SSD, this is kind of the bit that can get the hottest. The other parts of an SSD can afford to get a little cooler. You know, the NAND, that's where all the data lives. That likes to be a bit warm. The memory, again, not too bad. And again, that doesn't get too hot. But it is the controller and the SSD, the controller of the SSD, I should say, where things are the most important. In both cases, the SSD is encased inside the respective heatsinks, and both of them are using one large thermal pad covering the entire SSD. So, the Eleten there, again, that started a slightly higher temperature in terms of general use. I think the time of day was slightly different there, with the Elecgear starting at 30 and the Eleten there starting at 34. The rising between them, it has to be said, it definitely rose quicker overall in this testing on the Eleten when we look at them both side by side. The Eleten already rising quite noticeably early doors. The Elecgear already had quite an impressive low temperature to start with. Again, it took even when it broke into the 31s, that Elecgear, it didn't really rock the boat too much, and the Eleten there had a significant jump there. It even broke before the end of the testing there in that session. Obviously, you're watching the sped up session there. Even though they're on relatively the similar part of the game, I would still argue that it broke into the 40s in a way that the Elecgear, I could have played this for a few more hours, and I don't think that Elecgear would have broken into the 40C mark there. Yes, it started lower, but overall, as we made our way through it, the Elecgear made a total increase over gameplay of just 1.4C, the Elecgear there, whereas the Eleten, again designed for a PC, designed for open air utility, overall went up to 5.9C increase overall. So again, very small numbers and still well within the functionality of these SSDs, but still nonetheless, for Red Dead Redemption there, the controller throughout maintained a very low temperature there, just as I'd expect. But for now, let's repeat this test here, but this time we're going to look at the ambient temperature in the system on the node externally. So once again, we started from exactly the same spot, right there at the beginning of Red Dead Redemption there, making our way through the map. And as we made our way through it, again doing the horseplay there, occasionally I did die during the testing on both of these. So again, when that happened, that didn't affect things too much. It would just be a case of restarting, and that didn't really affect too much of the difference between different SSDs being tested. The other thing I'll highlight here is that the ambient around temperature, that's the inside of the temperature of the PS5 outside of that storage bay, so the second node there, this was conducted on both of these systems directly after the controller test. What would happen is, I'd finish the controller test that you just witnessed prior to this, PS button out of the game and close the game, leave the system for 1 minute in idle but not turned off, and then reboot the game back in. So straight away, as you can see there, the Eleteng there is maintaining its very similar surrounding temperature between them. Remember, this is, in my opinion, a far more important comparison of these two SSD heatsinks, because in this case, this is about the impact of the individual heatsinks dissipating their own heat into the area, and how that impacts the surrounding temperature, because that can be quite detrimental to the CPU and the GPU inside. Now, as you can see, with both of them starting very early, with the Eleteng starting at 23.1, the Eleteng starting at 24.4, and the Elecgear starting at 23.1, very close, just a little over a single degree between them. But as things move forward, you can see there that the Eleteng hasn't even reached the temperature. The Elecgear hasn't reached, two similar names, super annoying. The Elecgear hasn't even touched into the same region that the Eleteng started at. I know, so we weren't going to look at the numbers too much, but that's still worthy of note. And as both of these kind of draw to the end of their respective sessions, I know we're watching them on speeded up, the Eleteng ultimately over the course of this ended things at 23.2. That's 0.1 degrees. That's 0.1. That's crazy. Whereas the Eleteng at the end there, that PC brand one, that was 1.5. So the Elecgear, again, significantly better. More than 10 to 15 times more the heat dissipation overall, and less of an impact on the overall system. So that's Red Dead Redemption. We're going to make our way over now to Grand Theft Auto, repeating the same tests to see just how it appears in a different game between them there. But ultimately, the Elecgear is still doing remarkably well. Okay, so straight away, exactly the same thing again, but this time taking advantage of GTA. This is the offline mode, and what we did was hail a taxi and then drive to a very far off part of the map. For those that aren't aware, in GTA, taxis move extraordinarily slow unless you pay extra in the cab. So again, this was really ideal for allowing us to move through the city in a similar fashion as possible with every test, while simultaneously ensuring that we weren't taxing the game too much or too little all the way through. So we, Eleteng, that low-profile $10 heatsink there, started at quite a high 40C. Now, this was unavoidable. This was recorded quite a while ago and was quite a warm time of day. So consequently, that 40C is where we started at. Now, the Elecgear started at 26.7C, so a much lower temperature there overall. But what was particularly interesting during the course of this testing is, in the case of the Eleteng, nothing really changed that much. It was quite an average temperature change all the way through, and overall, as we saw it moving throughout the game, it was quite a solid, reliable temp test. Now, GTA does a lot of front-end loading, more so than Red Dead Redemption, but still nonetheless, it was quite an impressive temperature change, or at least minor temperature dissipation there all the way through. It's impossible to ignore that it's still a lot higher a temp, and it didn't dissipate that heat lower, but at least we didn't see it go significantly higher. Now, in the case of the Elecgear, there at the bottom, that PS5, you can see there that it's still remaining in the 25s. Now remember, when we tested Red Dead Redemption earlier, the temperature was at the 30C mark, starting at 30.8. This game started at 26.7 after a system reboot and a couple of minutes to cool down really did make all of the difference, and it was able to dissipate that heat between the sessions remarkably quickly. Now, as we draw towards the end of this test, I can tell you that right now the Elateng PC SSD heatsink ended things at 40.5 C, whereas the Elec Gear ended up ending things after this session on GTA at 28.1, an increase of just 1.4 C. Again, very good and near enough identical to that of the Red Dead test that came before it. Again, maintaining a lower temperature overall, even if we try to overlook the different ambient starting temperatures. But for now, let's move on to our second test using GTA, this time focusing on the general system temperature outside the SSD. Now, the ambient temperature of the PS5 during our second test was actually quite surprising. Now, I mentioned earlier on in the previous test that the Elateng PC heatsink there started at 40 in our previous test. Well, the ambient temperature inside the PS5 outside of that slot in this time started at 32.C. Now remember, this is just a minute and a bit after our previous testing. So again, a lot of dissipation there when we came out of the game. Now, in the meantime, the Elec Gear heatsink started at 21.8, so again, significantly lower ambient temperature there all the way through. Now, this was really reassuring, because the last thing you wanted in this test was that larger heatsink that lived outside of the M2 SSD slot was going to end up soaking up all of the ambient air, and therefore the thermo node that we placed after it was going to have a hotter temperature as hot air came out of the heatsink, because that would have been really detrimental to the internal CPU and the GPU of the PS5. Now, as we move through this, you can see again lots of different things happening there on screen as we make our way through the city. It's still fairly pedestrian, but there's always the surrounding stuff. So a little bit of IOPS work there, with most of the sequential data loading has already been done at the front end, and kind of light texture stuff there in the background. But the really interesting thing is, in this scenario, the Elateng did remarkably well. That Elateng there working in the background has already kind of kept things at 32C. There was a spike which it started to come down from, and this is one of the rare occasions testing not only this heatsink but just general all of the heatsinks that I've tested so far, that it actually dipped and was a lower ambient temperature all the way around. Now, this is a big vote for the idea of the SSD living inside that bay, because if it's living in that bay, it's not producing heat to interrupt or enter the rest of the system. And the Elateng PC heatsink actually started minus 0.3 C towards the end, whereas the Elec Gear ended up raising the ambient temperature to just a single 1.1 C all the way through. Very, very small increase, incredibly small indeed, but still higher than the Elateng. Now let's make our way over to some transfer tests. We're going to transfer over a little over 350 gig onto the internal PS5 SSD, and then write a 350 gig onto this heatsink equipped SSD. Let's begin that test now. So the first thing we wanted to do was test the read activity here on the SSD inside this heatsink. So all of the games that I tested plus a few others made up a little over 350 gig. So what I wanted to do was transfer the 350 gig of data on the SSD that we're utilizing today inside the heatsink back onto the PS5 SSD. So in this case, the Elateng PC heatsink, that started at 40C for the controller. We're only looking at the controller here, whereas the Elec Gear started at 29, significantly lower overall. So as we were moving this data over, obviously there is the usual restrictions. The PS5 does a lot of compression and shrinking and encryption of data as it transfers over. So we're not looking at the standard read and write here. What we're looking at is the temperature difference. And between the two of them, it looked even early on that the Elec Gear was going to be the one that had the lowest heat generated. The Elec Gear closing in, it ended things at 35.6 C, so a raise of 5.6 C overall. The Elateng PC heatsink there started at 40 and ended at 46.2, an increase of 6.2. Only a minor difference, and heat increases on read activity aren't unheard of, but still nonetheless, this wasn't an enormous increase and quite pleasing for both of them. Now, when we look at those results, those are still quite meaningful results between the two of them, and the dissipation afterwards in the case of both heatsinks was very, very quick. But of course, read activity utilises less aggressive and power absorption onto the SSD compared with that of write. So what I wanted to do next was move these games back from the PS5 SSD and onto the M2 SSD. Let's go ahead and do that now. Now, moving data from the internal PS5 SSD and onto the M2 SSD that we're looking at today will always generate a little bit more heat. The PS5's internal SSD currently has a read speed reported at around 5,500 megabytes per second uncompressed. Now, the SSD we're utilising today had a write speed well in excess of 5,500, approaching that of 6. So again, plenty of performance there, although there is of course the PS5's internal compression causing something of a bottleneck as it changes the shape of those files and adds some encryption. Now, the L10 heatsink started at 31.1 C. The Elec Gear started at 24. Once again, a much lower starting ambient temperature there on the SSD and its controller, with that copper heat pipe really doing its job. But unlike the read testing that we just performed, the heat being generated here is going to be notably higher. Now, the L10 leapt into the 40s particularly quickly. Indeed, although the write action only took around 5 to 6 minutes overall, and of course we've sped it up for you here on screen, it's worth noting that even in that short amount of time, the Elec Gear broke into at least 10 C higher very quickly. It did slow down as it got to the higher peaks, but the early high increase of that temperature was noticeable in the extreme. The Elec Gear, with its copper heat pipe there, it did raise into the 30s, but slowed down a great deal quicker. Overall, between the two of them, obviously the Elec Gear had a lower temperature to start with and ended lower as well. The increase between them was close and arguably of a similar percentage to before, but it was still a win for the Elec Gear, with the L10 PC heatsink there overall increasing it to 15.4 C, and the Elec Gear PS5 designed heatsink having an increase overall by the end of 12.1 C. Now again, these are still quite small numbers and well within the performance I would expect. However, between the two of them, it's still great to know that you are going to end up in heavy write activity, which is quite a rare occurrence for most PS5 users, only when you're downloading games or migrating or exporting games around your system. It's still good to know that the temperature increase on the Elec Gear was able to stand up and keep that temperature low during our heavy write activity. It's still quite an expensive SSD heatsink, but it's an impressive number nonetheless, and ultimately kind of backs up a lot of their claims in these rather more aggressive, if arguably rarer scenarios of using a heatsink in your PS5. The L10 did its job well, but it just couldn't stand up to the PS5 designed heatsink here. And if that's what's important to you and you're planning a lot of write activity, results like these really will stand out for you. So let's summarise what we've learned today. So there you have it. That was the temperature testing of that Elec Gear. Let's be completely honest, in all but one occasion, it absolutely smashed that of the L10. We kind of expected that all the way through. It was only on one occasion throughout those tests that there was ever kind of a slight sway towards the Elec Gear, and even then it wasn't that much. Now, there's a few things to bear in mind now. The price difference between these two is quite notable. Depending on which region of the world you live in, the Elec Gear knocks around for about 3 to 4 to even 5 times the price the minute you include tax and shipping there. It is not a cheap SSD heatsink there. Yes, the Elec Gear is designed for PC use primarily, but it still fits inside that slot. And a lot of people's big problem with these minor heatsinks here is when they go inside the PS5 slot there, it's then covered by that metal panel inside the little M2 cavity, which then causes all kinds of temperature, not a big old noise like I did there. So again, for me personally, I'm slightly swayed because much like my review of the Eno Heat Pipe SSD heatsink there, which, if it's not already live, should be very, very shortly. This feels a little bit overkill. I really like the Sabrent one, and we're going to be doing a full comparison against that, but I don't know why this one feels, for its price tag, a little bit pricier than it should be. When the Sabrent arrived on the scene at $25, yes, it was more expensive than these by 2 to 2.5 times, but that was the first PS5 heatsink that was designed for that slot, and as our test showed, it really did maintain the temperature exceptionally well. But in the case of the Elect Gear, it's notably more expensive, and it's not the first one to market, which seems really odd to me that they've still stuck with that pricing strategy. Now, maybe this is a price drop that's a little bit late, and they should have done that by now. I can't argue with it's doing its job. It's certainly doing the job, and much like I said in my hardware review, you can't fault the design at all. But still, nonetheless, I do think if you don't see this, or if you see this and it doesn't have a discount, I should say, then maybe give it a little while, because right now, for what you're paying, it's not quite as good as it thinks it is. Once it gets down to about $15 to $20, then, my friend, jump on the bandwagon. But till then, I think this is just a little bit too pricey for what it is. If money isn't a problem and you're just thinking long term, and you do extensive daily gaming, that's a different conversation, and chances are you're going to spring the little bit extra and maybe have a couple less pints this week to pay for it. But this has been the temperature testing of the Elect Gear PS5 heatsink. As I've mentioned previously, we've got extensive comparisons not only between heatsinks like the Sabrent PS5 and the Enotech Copper Heat Pipe PS5 SSD heatsink, but also against the likes of the WD Black and the Seagate Fire CUDA first-party SSD heatsinks to come up, so do stay tuned for that. But if you've enjoyed this video or found it helpful, click like. It genuinely helps the channel and helps me understand what I'm doing right and wrong. If you want to learn more or stay tuned for when those other heatsink videos get live, click subscribe and the bell to be notified, because this will be something we're continuing more and more this month and the start of the next. And of course, if you need free advice or still wondering about the right SSD you need for your gaming system, use the free advice section in the comments. Genuinely free, and it's linked in the description. Two humans, me and Eddie the web guy. We answer your queries, we make recommendations. It's free, we do nothing with your email, it's unbiased. It's two humans. It might take us a day or so to answer your email, because there's quite a lot of messages we get every day, but we try to answer every one. Thank you so much for watching, and I will see you next time.